We're going to look at a problem here where we have a ladder leaning up against a wall. So we've got the ground, and we've got our wall. Our ladder is going to be leaning at a 70-degree angle. So we've got our ladder like that. And this is 70 degrees down here. And there's a person on the ladder 4 meters up, and the ladder itself is going to be 5 meters long. So the whole ladder is 5 meters, but there's a person standing right here, and that is 4 meters up the ladder. We know that the mass of the ladder is going to be 20 kilograms. And we'll just use ML for that going forward. And the mass of the person is going to be 60 kilograms. We'll call that MP going forward. And what we want to do is a couple things. We want to figure out all the forces on the ladder. Making one assumption that this contact point up here is frictionless. That doesn't mean the wall can't be pushing on the ladder, but there's not going to be any up or down pulling force from friction. But otherwise, we can have friction down here, and certainly the ground can push up on the ladder, and the wall can push in on the ladder. In addition to finding all the forces on the ladder, we would like to figure out what is the minimum coefficient of static friction between the ground and the ladder in order to not slip. So, to deal with this, we are going to turn this into a sort of free body diagram and figure out what relationships we can come up with. One thing we do want to recognize right away, if this ladder is just leaning up against a wall, everything should be at rest. And so this is going to be a static equilibrium problem. We can use all of our static equilibrium conditions. All right, so I'm going to sort of redraw a simplified version of my diagram. I'm not going to draw the actual steps of the ladder or anything. I'm just going to draw the ladder itself. And the person, instead of drawing our little stick figure, I'll just put a little dot to represent the person. And in terms of forces, there's going to be a force of gravity that's pulling down on the person. There's also going to be a force of gravity pulling down on the ladder itself, and that's going to act on the center of mass of the ladder, which is, right in the center of the ladder. And so there's going to be a force of gravity pulling down on the ladder. The ground here is going to be pushing up. Certainly there's going to be a normal force from the ground pushing up. So we'll call that the normal force with the ground. I'll call that FNG. To differentiate that from the wall is also going to be pushing outwards with a normal force. So we'll call that FNW. And then there should also be some friction with the ground. If there was no friction, we can imagine the ladder would just sort of slip that way. And so the friction must be pulling this way to keep the ladder from slipping. And so there's got to be a force of static friction here. And we need to figure out what all of these forces are. So we have 5 things that we need to solve for. 2 of them are pretty straightforward to find. The force of gravity on the person and the force of gravity on the ladder is just going to be m times g. So the force of gravity on the person is the mass of the person times g, which is going to be 60 times 9.8, which is